Alrighty, howdy folks. Last section in chapter 6. We are continuing with the rate of return, but section 2 covers external rate of return. I hope you recall that in section 1 we did internal rate of return, but now we are going to learn about something called external rate of return. Okay, what is this about? The external rate of return, ERR, is calculated by the formula sigma t equals 0 to n r sub t 1 plus r to the n minus t equals blah, blah, blah. Okay? All right. What in the world is each one of these things? Now that we need to spend a little time trying to understand this. R sub t is the positive valued cash flows in a cash flow series, right? Does it make sense? I mean, in a cash flow, would you agree that there would be some negative and there would be some positive cash flows? So what you do is you take all those positive cash flows and okay, let's say there is a positive cash flow at t equals 1. Well, what do you do apparently? That whatever that r sub 1, that's a positive cash flow, uh, times 1 plus r raised to n minus t. What are we doing when we do that? All we're doing is we are finding the future value at t equals n of whatever is occurring at t, the positive cash value occurring at t. If t is 1, then we are talking about how much ever that positive income is, r sub 1, times 1 plus r raised to, if n is 4, then 4 minus 1. So we are projecting this one to the future n equals 4 in that case. As simple as that. Similarly, there may be another positive cash flow at t equals 2. We are finding the future worth of that also, and so on. So all the positive cash flows, we are finding the future value of them on the left-hand side. Cool. The question is, what in the world is R? Okay, that I need to answer. N is the total planning horizon. T is the year in which it's occurring. Or R is, I'll tell you that it is in fact the minimum attractive rate of return. Okay, now let's look at the right hand side. C sub t, on the other hand, is the absolute value of the negative valued cash flows in a cash flow series. What they mean by is, why the absolute value? Let's say there is a negative 10,000 as an initial investment. Well, don't use negative 10,000 for C sub t in that case, C sub 0 in that case. Instead, use positive 10,000, right? That's all this is trying to say. Good. So, the negative cash flows, once again, you are projecting each one of those negative cash flows all the way to the t equals n. That's what you're doing by doing this formula. And eventually adding up all those negative cash flows. Okay. Now then there is this I prime. Aha, there is an R here and there's an I prime here. What's up with that? The thing is, this I prime is the one which is the external rate of return. Cool. So you use the external rate of return I prime only for the negative cash flows to project them to the future. All the positive ones, you use your minimum attractive rate of return. Cool, that's the difference. R is the reinvestment rate or minimum attractive rate of return. N is the total time of cash flow or the planning horizon. And I didn't say what I prime is. Ugh. Note, okay, notice the formula simply states that the future worth of all positive cash flows using minimum attractive rate of return should be set equal to the future worth of all the negative cash flows using ERR in order to find the ERR, the external rate of return, I prime. Cool? All right. Now, the reason for introducing ERR is to overcome the issue of multiple routes with IRR. What? Apparently, one big advantage of this external rate of return as opposed to the internal rate of return is we saw that internal rate of return could have multiple roots. That was a little bit of a pain. But guess what? With the external rate of return, you have only exactly one value, right? How does that work? I have to admit, uh, I was preparing for this lecture. Uh, I had these PowerPoints made long time back, but recording this lecture is happening now. And so when I was looking at this one, I was like, why? Uh, because there is a polynomial here, obviously, right? Ct 1 plus I prime to the n minus t. This could be to the 4 plus cube plus square. So we have a polynomial, fourth degree polynomial. Who says that wouldn't give you, multiple roots, multiple positive roots? It would have multiple roots. That's for sure. But the claim is there is only one positive real value root for this one, is the claim. And I was like, why is that? And then it hit me. Then it occurred to me, dang, that stupid Descartes rule of signs. I I need to use that. If I use that, I'm in business, right? Tell you what, when we get to the very last problem, I'll show you. Initially, I don't think I can show you what's the big deal about this. Why is it that you get only one root for this external rate of return? I'll show you that. Cool. It is evident that ERR is a single value that satisfies the equation. Apparently, there's only one value. Cool. The investment of $500,000 in an SMP machine is expected to reduce manufacturing costs by $92,500 per year. At the end of the 10-year planning horizon, it is expected the SMP will be worth $50,000. Using a 10% minimum attractive rate of return and an external rate of return analysis, should the investment be made? Okay. The positive cash flows. What are the positive cash flows? The investment of 500,000, is it? Nah. It reduces the manufacturing cost by $92,500 per year. That's money in your pocket. So the 92,500. What else? And will be worth 50,000. So there is another one at 50,000, which is going to happen at t equals 10. So there are a whole bunch of positive values, positive returns, uh, things that are occurring from 1 through 10, all of them equal to $92,500. But in addition to that, there's a 11th one. I shouldn't have. Yeah, that's a T. I don't know. I'm not so sure about calling this. Only to avoid this one, I guess. Anyway, so some R happening at T equals 10. And the negative cash flow or negative cash flow is or negative. There's only one cash flow, negative cash flow, $500,000 at T equals 0. Would you agree? All right. So what do we do? Minimum attractive rate of return. In this case, we are supposed to apparently call it lowercase r, and that is 10%. That is 0.1 per year. Q ERR is I prime, and the thing is, what in the world is ERR? That's what we need to find. So if we do this, sum up all the positives. Well, these are 92,500 occurring every year from t equals 1 to 10. And we know how to find the future value. 92,500 times 1 plus 0.1 to the 10 divided by 0.1, right? We are using R. So that all the uniform payments, uniform series payments, future value. Plus this value is occurring at t equals 10. So it's already a future value. We are simply adding that. And ladies and gentlemen, that turns out to be this number. Cool. Now let's do the same thing. Project the C sub 1 at 500,000 all the way to the front. But this time we'll use 1 plus I prime. So the ERR for the interest. And what do we need to do? We need to set these two quantities equal. So we do that. Cool. All right. Now, maybe I could give you a heads up on the answer to that question. Why is it that this I prime thing gives only one value? There is only one root that satisfies this. Check this out. This is a 10th degree polynomial in 1 plus I prime, therefore in I prime. So there must be 10 roots. But the thing is, if you write this as a polynomial equals 0, this big blah blah minus this big number is equal to 0. Right? Now, how many sign changes is it going through? Initially, it is positive 500,000. That's the coefficient. And minus 1 million blah blah. So there is one sign change that is occurring, at least in this case. And that guarantees us that there is only one positive real root. Right? That's the idea. Yeah, but if you say, ah, that's only because this has got only one thing, right? What if there is a 1 plus I prime times 10 to the 8, 10 to the 6, and all these things? That's a term, that's a polynomial with a whole bunch of other terms containing 1 plus I prime, the powers of 1 plus I prime, right? So what happens in that case, you might ask. So if you are asking that, then you are asking a really good question. You should pat yourself on the back and go, "Atta boy, what an awesome job I did. What an intelligent guy I am." Right? That's what you should do. Anyways, so this turns out to be, some algebra. Solve this. Oh, that's interesting. Do you need to use logarithms? No, you don't. This raised to 10 equals 3.04. So you want to find 1 plus I prime? Take the 10th root on both sides, right? That's what taking the 10th root is nothing but raising to 1 over 10. And that's equal to this guy. So 1 plus I prime is this. I prime itself is this, which turns out to be 11.791%. So, ladies and gentlemen, the external rate of return is 11.791%. Should the investment be made? Wait, is the... Oh, no, I didn't answer that question. If the external rate of return is bigger than the minimum attractive rate of return, right? Should you invest? Yes, of course. This project, this machine, this investment in this machine is giving you a rate of return which is more than your minimum attractive rate of return. So yes, you should. Cool. All right. Galvanized Products is considering the purchase of a new computer system for its enterprise data management system. The vendor has quoted a purchase price, blah, blah. Okay, I think we did this problem at least twice. And so the only difference is we need to do external rate of return thing. Okay. We'll find the loan payment, right? That's what we did. If you recall, you can pause the video and just go over the problem more carefully. $100,000, 25,000, 1/4 of it, which is $25,000 has been borrowed as a loan, and these are the loan payments. So 10,949. Okay, for 3 years. The whole planning horizon is 5 years, but for 3 years you will be paying off this loan on this 25,000 that you borrowed. Okay, keep that in mind. And now let's look at all the other things and ask ourselves, what are the positive cash flows, or what is the future worth of all the positive cash flows? Cool. Okay. Uh, First, I have 25,000 uh, being projected to t equals 5. What is this 25,000? The loan that we took out. The bank gave us 25,000 at t equals 0. So that's a positive cash flow. And we are projecting it all the way to t equals 5. And then let's look at this. What is that? We would be saving 55,000. Yeah, but the system will save $55,000 per year through increased efficiencies. So that's a positive cash flow. So, and they are uniform series. So for each of those things occurring at each of those years, t equals 1, 2, 3, 4, 5, project all of that to the future by using this formula, and we got the positive cash flows of that taken care of. And on top of it, there's a salvage value of 5,000 that's occurring at t equals 5. So we'll just add that number. And so when you sum up all these, you get 455,675. These are the positive cash flows. Cool. Now let's look at these negative cash flows. The loan is a negative cash flow, right? That you have to pay at t equals 1, 2, 3, that one. And also this, what is that? The initial investment of 100,000, right? That 100,000 projected to the future t equals 5. And this guy, take a look at this guy. This is the only one that's perhaps just a little, yeah, requiring a little clarification. Let me explain this. So there is at 1, 2, and 3, t equals 1, 2, 3, there's a negative, there's a 10,949 thing, right? So if you project it to t equals 3, right, at the end of the t equals 3, for that, would you agree you need to use this formula? To t equals 3. Now that you got a value of it at t equals 3, to move it to t equals 5, you need to multiply by 1 plus I prime the quantity square. That's what is happening here. If you can come up with some other way of doing this, perfectly fine. For instance, you could go 10,949.42 times 1 plus I to the 1 plus I to the 5 minus 1, right? This times 1 plus I raised to 5 minus 2 and raised to 5 minus 3. So that is another way, but they are all both the same. Cool. All right, what else? Oh, every year t equals 1 through 5, you are expected to pay a technician $25,000, right? So that $25,000 recurring at every one of those years is projected to t equals 5, and this using this formula. All right. Okay. So what do? We setting the two quantities equal and solving for I by trial and error method. We get I prime to be 17.56%. The decision rule is if ERR is greater than minimum attractive rate of return, buy, reject otherwise. Since ERR turned out to be 17.56%, which is less than our minimum attractive rate of return, reject, right? Okay, now let me see if I can explain why there are no multiple routes. There's only one route. This may not be a bad idea. All said and done, this is a sixth degree polynomial in I prime. But we have only raised to 5. Yeah, but the thing is there's an I prime in the denominator, right? So what we'll do is we want to get rid of this I prime in the denominator and we'll multiply by I prime, the whole thing. If we do that, we have a I prime times 1 plus I prime to the 5, and that when you multiply, you get I to the 6 plus some other terms. Cool. And over here, we already have a 1 plus I prime the quantity cube and times a 1 plus I prime quantity square. That is a fifth degree polynomial. I'm assuming that we have already multiplied by I prime, okay? So we would have a fifth degree polynomial when expanded, when this is expanded, and this will also be a fifth degree polynomial. The only thing would be this one is the sixth degree polynomial, the first one, and the remaining ones will be fifth degree polynomials. Okay. But overall, therefore, this is a sixth degree polynomial on one side of the equation. And on the other side, we just have a number. And so if we subtract this number and set that equal to 0, right, we have a sixth degree polynomial minus some constant equals 0. But sixth degree polynomial should have 6 roots, man. What if there are 6 positive real roots? The answer is no. Notice, there is only one sign change. All of these powers of I are all positive. The only sign change occurs when we go minus this 455, 675. So that's the only sign change. And therefore, we are guaranteed there's only one positive real root. Cool. All right. I hope that makes sense. I have a feeling understanding stuff like that is a cool thing to know. Anyway, amigos y amigas, adios.